only the magnitude. Why? At the end of the result I say 1 proton, 1 electron, easy to analyze, whose charge is plus Ze, charge of the nucleus. R equals n square, h square, epsilon naught, configuration of the electron from the field of the nucleus provides it. Hello students, continuing my discussion on the chapter atoms. In today's class, I shall derive 3 tropical expressions, classical expressions. First, radius of the stationary orbit, velocity of the electron in the stationary orbit, and finally the total energy of an electron in the stationary orbit. Therefore, we start deriving an expression for the radius of the nth stationary orbit of an hydrogen atom. Very, very important. Using Bohr's theory framed on the principles of Bohr's postulates, I am deriving an expression for what? For the radius of nth stationary orbit of hydrogen atom. And remember, this is a very important 5-mark question often asked in the exam. And all these derivations are connectors. If you learn one derivation thoroughly, the other 3 is simply a cakewalk. My dear students, yesterday we studied about the stationary orbits. Why is Bohr calling the electron orbits as stationary orbit or non-radiating orbits? It is because as long as the electron is in that particular orbit, as long as the electron stays in that orbit, it will not radiate any energy. It will not lose any energy. Therefore, it is called stationary or non-radiating. Why in specific hydrogen atom? It is the simplest atom. 1 proton, 1 electron, easy to analyze. It is not complex in nature. So, we are considering hydrogen atom as the reference, and we derive expression for radius of the hydrogen atom. Now, to begin with, I will consider an electron. An electron of mass m and charge E minus. There is an electron whose mass is M, whose charge is E minus, which is revolving around a nucleus, and nucleus of the hydrogen atom. So the electron revolves around the nucleus of the hydrogen atom, whose charge is plus Ze, charge of the nucleus plus Ze. How did I write? I will refer to it in the nuclei chapter. Now just do remember that the nucleus has a charge plus Ze and the electron has a charge minus E, and for hydrogen very well we know Z atomic number is equal to 1. So to summarize whatever we have studied, there is an electron whose mass is M, whose charge is E minus. It is revolving around a nucleus of hydrogen atom, whose charge is plus Ze, charge of the nucleus. And since it is hydrogen, Z is equal to 1. Now, very basically from Bohr's postulate, we have understood why electron revolves around the nucleus and not fall into the nucleus. Niels Bohr is giving a condition where Fe is equal to Fc. What was Fe? Electrostatic force between the nucleus and the electron. What is Fc? Centripetal force acting on the electron. And therefore, the first part of the derivation, it is very important that we calculate this Fe and Fc. Now, how do I calculate this Fe? Recall Madi? Fe, force of attraction, electrostatic force between two charges, nucleus and electron. The moment I say charges, the moment I say electrostatic force, it has to be Coulomb's law. So I am making use of Coulomb's law to calculate the electrostatic force. Makle, Coulomb's law na recall ಮಾಡಿ. Fe, electrostatic force equals 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Very much established when I did the first chapter. From Coulomb's law, the electrostatic force between any two charges, 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Now applying Coulomb's law for my hydrogen atom, Fe equals 1 by 4 pi epsilon naught. Q1 I call the charge of the nucleus, which is plus Ze magnitude. Q2 charge of the electron minus E itto, but I take the magnitude of the charge E. I repeat, Q1, yes, it is the charge of the nucleus plus Ze. Q2, charge of the electron minus E itto, but I am taking only the magnitude. Why? At the end of the result I say. So Fe equals 1 by 4 pi epsilon naught Z E into E square, distance between the nucleus and the electron, orbital radius I call R. So this is the expression for electrostatic force. So in the first part of my derivation, I have calculated the electrostatic force between the nucleus and the electron, which is 1 divided by 4 pi epsilon naught Ze square by R square. Next, what do I calculate? Centripetal force. The centripetal force acting on the electron. What is it equal to? Very much by mechanics you have studied. Centripetal force Fc equals mv square by R. We have to be exposed to these results. So I have Fe, which is the electrostatic force, Fc, which is the centripetal force. Now, boss, Mr. Niels Bohr says this Fc should be equal to Fe. Very much established from the first postulate. Now I substitute here. Fc ಏನಾಗಿದೆ? mv square divided by R. Fe ಏನಾಗಿದೆ? 1 by 4 pi epsilon naught Z E square divided by R square from equation 1. So I have substituted for Fc as well as I have substituted for Fa. This R and 1 R gets cancelled. I take this R to the numerator on the left hand side. mv square R equals numerator alli ಏನಿದೆ? Ze square divided by 4 pi epsilon naught. ಮಕ್ಕಳೇ, ಈಗ ಈಕ್ವೇಶನ್ 3 ಅಲ್ಲಿ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಗಮನಿಸಿ. ಎಲ್ಲೋ ಒಂದ್ ಕಡೆ ಎಂ ಇದೆ, ಮಾಸ್, ವಿ ಇದೆ, ವೆಲಾಸಿಟಿ, ಆರ್ ಇದೆ, ರೇಡಿಯಸ್. ಈ ಕ್ವಾಂಟಿಟೀಸ್ ನನ್ಗೆ ಯಾವ್ದಾದ್ರು ಟರ್ಮ್ ಕೊಡುತ್ತಾ? ಗುಡ್. ಆಂಗ್ಯುಲಾರ್ ಮೊಮೆಂಟಮ್. ಸೊ ನಾವು from the quantization rule, Third postulate, quantization of angular momentum ಅಂತ ಓದಿದ್ವಿ. According to that, MVR should be equal to NH divided by 2 pi. ನಂದು ಪ್ರೀವಿಯಸ್ ಸೆಷನ್ ನೀವು ಬೋರ್ಸ್ ಪಾಸ್ಟುಲೇಟ್ಸ್ ಮೇಲೆ ನೋಡಿದ್ರೆ angular momentum, which is MVR, should be equal to NH divided by 2 pi. I'll retain only V on the left hand side. So M comes to the denominator, R comes to the denominator. So V equals NH divided by 2 pi ಆಗ್ಲೇ ಇದೆ. M and R, they also come to the denominator. So repeating again, from the Bohr's quantization rule, M V R equals NH divided by 2 pi. Retaining V on the left hand side, NH by 2 pi there, M and R also come to the denominator. Now, substitute V in equation 3. ಗಮನಿಸಿ, equation 3, left hand side in ಗಮನಿಸಿ, M V square ಇದೆ. I have extrapolated the value of V. V ಎಷ್ಟು ಸೂಕ್ತ ಬೆಲೆ ಅಂತ ನಾನು ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ವಿ ಅನ್ನ ಈಕ್ವೇಶನ್ 3 ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀನಿ. ಎಂ ವಿ ಏನಾಯ್ತು? NH divided by 2 pi MR. ಇಲ್ಲಿದೆ ನೋಡಿ, ಇದನ್ನ ಇಲ್ಲಿ ಹಾಕೊಳ್ತಿದ್ದೀನಿ ಅಷ್ಟೇ. V ಸ್ಕ್ವೇರ್ ಇದೆ into R ಇದೆ. Right hand side is ZE square divided by 4 pi epsilon naught. So I am simply substituting the value of V in equation 3. This is M square ಮಾಡಿ N square H square, 2 square is 4, pi square, M square, R square into R is ZE square 4 pi epsilon naught. Now rearranging these terms, M and M gets cancelled, 4 and 4 gets cancelled, 1 pi and pi gets cancelled. What remains is R equals N square H square epsilon naught divided by pi M Z E square. If you observe, students, this is the expression for radius of the stationary orbit. R equals N square H square epsilon naught divided by pi mz E square. Now, since I have considered hydrogen atom, Z has to be equal to 1. ಇಲ್ಲಿ ಯೂಶುವಲಿ ಒಂದು ಮಿಸ್ಟೇಕ್ ಮಾಡಿ ಕೊನೆಯಲ್ಲಿ ಅಷ್ಟು ಬ್ಯೂಟಿಫುಲ್ ಆಗಿ ಡಿರೈವ್ ಮಾಡಿದ್ರು ಯು ಲೂಸ್ 1 ಮಾರ್ಕ್. ಇಫ್ ಯು ಡೋಂಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ Z is equal to 1, then a mark is deducted, because very specifically I told this is hydrogen atom. So substituting Z equals 1, R is N square H square epsilon naught divided by pi M A square, and this is the expression for radius of the orbit. Now very clearly h is a constant, alva, Planck's constant. Epsilon naught, constant. Mass of the electron, constant. Charge of the electron, constant. The only thing that varies is the orbit number. Therefore, ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ radius is directly proportional to n square. Very important result idu. Radius of the stationary orbit in an hydrogen atom is directly proportional to square of the orbit number. So R is directly proportional to n square. And the very first orbit of the hydrogen atom is called the Bohr orbit. Nenpitkolli, n equals 1, first orbit of the hydrogen atom is called Bohr orbit, and the radius of that first orbit, radius of the Bohr orbit is called Bohr radius. So ಈ ಎರಡು ಇನ್ಫರೆನ್ಸ್ಗಳು very important. Radius is directly proportional to square of the orbit number. First orbit is called Bohr orbit and the radius is called Bohr radius. Now, the second derivation is to derive an expression for orbital velocity. Velocity of an electron in a given orbit of the stationary orbit. It exactly goes the same way as I derived for radius. So I expect you all to do this as an assignment. Just refer to the previous derivation. Simplify the same steps. Instead of getting R, get me V. Now, but I would like to discuss the final expression. Velocity of the orbit is E square divided by 2n h epsilon naught. ನೀವು ಡಿರೈವ್ ಮಾಡಿದಾಗ ನಿಮಗೆ ಈ ರಿಸಲ್ಟ್ ಸಿಗಬೇಕು. Orbital velocity is E square divided by 2n h epsilon naught. Again, charge of the electron constant, Planck's constant, epsilon naught constant, which means velocity is inversely proportional to orbit number. Andre, in the innermost orbits, electrons move with faster velocities. As the orbit number increases, the velocity of the electron should decrease. That is the implication of the result. V proportional to 1 divided by n. In the innermost orbits, nearer orbits to the nucleus, electron has more velocity or moves faster compared to the orbits far away from the nucleus. So understand, V is always proportional to 1 divided by n. Now going to the most important, by all means you can expect this derivation, a 5 marker again for the examination. Here I am deriving an expression for total energy, not simply energy, total energy of an electron, again in the nth stationary orbit. Step by step follow ಮಾಡಿ. This is very important. Total energy of an electron in the nth stationary orbit. So my dear students, what do you mean by total energy? It is the sum of the potential energy and the kinetic energy of a system. First PUC ಓದಿದ್ದೀರಾ? Total energy of any system is the sum of the potential energy and the kinetic energy of that system. Which means when I say total energy of an electron, it is the sum of the potential energy and the kinetic energy of the electron. Now, I know electron will possess kinetic energy because it is continuously moving around the nucleus. Recall ಮಾಡಿ, expression for kinetic energy ಏನು? Kinetic energy is half mv square, where v is the velocity of the electron. The electron continuously moves around the nucleus. It has orbital velocity and hence will possess kinetic energy. But my question is, where is the potential energy coming into picture? Your higher definition says potential energy is due to position. Potential energy is due to configuration. Please to remember, students, an electron is under the influence of the field of the nucleus. The position of the electron from some distance from the nuclear field is making the electron get the potential energy. Configuration of the electron from the field of the nucleus provides it the potential energy, and the sum total of this is what we call total energy. So first we will calculate the potential energy of the electron. Now I use this definition. Potential energy of the electron is potential due to certain distance from the nucleus, configuration of the electron from the nucleus into charge of the electron. Potential due to certain distance from the nucleus, electron certain distance from the nucleus into charge of the electron. Now recall the expression for potential. V equals 1 by 4 pi epsilon naught Q by R, charge of the electron, Q by R. So 1 by 4 pi epsilon naught potential due to certain distance from the nucleus, q charge of the nucleus, go back, charge of the nucleus is Ze, distances r, into charge of the electron which is minus e. Sir, ill minus e ತಗೊಂಡಿದ್ದೀರಾ, ರೇಡಿಯಸ್ ಡೆರಿವೇಶನ್ ಮೈನಸ್ ಇ ಯಾಕೆ ಕನ್ಸಿಡರ್ ಮಾಡಿಲ್ಲ, ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಯಾಕೆ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರಿ? There, if I take the charge as minus e, radius becomes negative. You get a negative sign for radius. Length cannot be negative. Therefore, I took magnitude of the charge. Here, negative potential andre loss of energy in tartha, which can happen. So, I have taken minus sign. Therefore, EP is minus 1 by 4 pi epsilon naught Ze square by r, and this is the expression for potential. Q by r ಇದೆಯಲ್ವಾ, ಅದನ್ನು ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಕೊಳ್ಳೋದು. ಫಸ್ಟ್ ಚಾರ್ಜ್ ಆಫ್ ದಿ ನ್ಯೂಕ್ಲಿಯಸ್ ವಿಚ್ ಇಸ್ Ze into charge of the electron E with a negative symbol, and this gives the potential energy of the electron. Now, kinetic energy of the electron is half mv square. We will now calculate the kinetic energy of the electron again by using our Bohr's atom model, postulates of Bohr's theory, which says Fc is equal to Fe. What we did in the first derivation again. Fc, heli nodana, centripetal force gain expression, very good. mv square by r, Fe 1 by 4 pi epsilon naught, Ze by r square minus e, charge of the electron. R and r gets cancelled. mv square equals 1 by 4 pi epsilon naught Ze into e is square by r. Now, so substituting back mv square, so we have half mv square. Now, I know the total energy is calculated as EP plus EK. Here, I know the expression for radius. Substituting, the total energy is written as minus m Z square e to the power 4 divided by 8 n square h square epsilon square. Substitute for potential energy, substitute for kinetic energy. Illೊಂದು minus ಇದೆ, therefore you get a minus. Again for hydrogen atom, Z is 1, so E is minus m e to the power 4 8 n square h square epsilon naught square, and this is the expression for total energy. Here, what is that negative sign showing? The negative sign shows that if you have to remove an electron from the field of the nucleus, ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ನ್ಯೂಕ್ಲಿಯರ್ ಫೀಲ್ಡ್ ಇಂದ ಪುಲ್ ಮಾಡಬೇಕಾದ್ರೆ ಎನರ್ಜಿ ಹ್ಯಾಸ್ ಟು ಬಿ ಸಪ್ಲೈಡ್. You need to supply some energy so that you liberate an electron from the nuclear field. ಈ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ನ ಮತ್ ಪುನಃ ನೀವು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಬರೆಯಲ್ಲ, ಕೆಲವೊಂದು ವ್ಯಾಲ್ಯೂಯೇಟರ್ಸ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತಾರೆ. ಸೊ ಪ್ಲೀಸ್ ಡು ರೈಟ್. The negative sign indicates that energy has to be supplied to remove an electron from the field of the nucleus. Now, therefore, if you substitute for all these constants, calculation maad nodi, again, n is the thing which is not constant. Energy of an electron in any orbit, you get minus 13.6 by n square electron volt. So very simple, just substitute the orbit number, you can calculate the total energy of an electron in that orbit. So my dear students, in today's session we have worked out expression for radius, expression for orbital velocity, expression for total energy. Please to take a pen and paper, practice these derivations. They are all mark earners for you all. The next session I'll be doing expression for the wave number of spectral lines and hydrogen spectrum. Until then, have a nice time. Thank you.